All right, so in this video, we're going to take a look at perimeter and area of similar figures. So the perimeter is a length around the outside of a shape. If figure B is similar to figure A by a scale factor, then the perimeter of B is equal to the perimeter of A times the scale factor. Okay, so we just multiply by that scale factor since it's a perimeter. A length is just around the outside. It's no different than if it was just the length of a side. If I wanted to know a scale factor from A to B and I had the scale, then I could multiply A times the scale factor to get B. Perimeter is the same idea, it's just the length all the way around. Okay, so if perimeter of B would equal the perimeter of A times the scale factor, or I could do vice versa. I may have to divide depending on if I'm going from a larger figure to a smaller figure, or going from a smaller figure to a larger figure. I have to pay attention which direction I'm going. So area is a two-dimensional space inside a shape. So that's, the actual space it takes up, not just a line or a length. So if figure B is similar to figure A by a scale factor, then the area of B is equal to the area of A times the square of the scale factor. I do have to square it. I have to take into account that it's two-dimensional. Okay, so let's go ahead and let's practice this. So if we have this scale drawing to find an actual area, so a scale drawing for a restaurant is shown below. In the drawing, 2 centimeters represents 3 meters. So they gave us a scale here. So we're given that 2 centimeters on the drawing represents 3 meters in real life. That is our scale. Okay, so here it is as a fraction, 2 centimeters to 3 meters. So drawing to real life. Assuming that the dining hall is rectangular, find the area of the real dining hall. So we only care about this rectangle here. I don't actually care about the kitchen. They're only asking me about the dining hall. So using the ratio, we will find the length of L and the width W of the real dining hall. Okay, so we're going to convert from the scale, from the drawing, to the real life. Okay, and then we're going to find the area. So the length of the dining hall in the drawing is 8 centimeters, and the width in the drawing is 4 centimeters. So let's convert this. So we have 2 centimeters to 3 meters. This is drawing to real life. So drawing is 8 centimeters, and the length in real life is what we're trying to find out real quick. So we're going to cross multiply. So we have 2 times L, and then we have 8 times 3 for our second cross multiplication. So now 2 times L just turns into 2L. 3 times 8 is 24. And now to find out the real length, I'm just going to divide by 2 on both sides because 2 divided by 2 will cancel, and that'll tell me that L is 12 meters. So in real life, the dining hall is 12 meters long. On the drawing, it's 8 centimeters. So now let's do the width of the dining hall. So I'm still going to use that same scale factor. Remember, this is drawing, this is real life. And now I'm going to do the drawing, the width of the drawing for the dining hall over W because I'm trying to find the real width. So I'm going to cross multiply again. So I have 2 times W, and then I'm going to cross multiply the other direction. So 3 times 4. So 2W equals 12 this time. And again, I'm going to divide by 2 on both sides to get that W by itself. So now I know that, that should say W, the width is 6 meters, not the length again. So now I can use the length and the width to find my area because the area of a rectangle is length times width. So area of a rectangle, length times width. So I'm going to go 12 times 6, and you could see the answer there a little too quick, but 12 times 6, that got me 72 meters squared. So I had to do a little bit of work here to convert from the centimeters to the meters before I could even do the area. Okay, so make sure you're paying attention. What are they asking you to find, and how are you going to get there? So I hope that helped, and I'll see you in the next video.